Alright, so this is Chapter 5, FN2, Graph Transformations and Inverses, alright? So this is very similar to what we did with the last standard, just by solving the inverses with algebra, except this time we're going to use actual graphs. And again, if you remember, when you're solving for these graphs, it's pretty straightforward in terms of figuring out what your points. You just got to make sure that you have the correct points in your function. So the first one that we're going to start with number 1 is the function f of x is equal to 2x squared plus 1. If you remember, this should be familiar because this is, in fact, a quadratic. So in this case, that quadratic is going to have a multiplier of 2, and then it's going to have a vertical shift of up 1, all right? So again, we're just going to go ahead and plug in some points here. I'm just going to start with that value of negative 2. If I do negative 2 squared, that's going to give me a positive 2, times 2 will give me a 4. Negative 2 squared will give me 4. 4 times 2 will give me that 8, plus 1 will give me a positive 9. All right, so that's our first point. Next one will be negative 1. Negative 1 squared, if you remember, so negative 1 times negative 1 is 1, times 2 is a positive 2, and then, plus 1 will give me a 3. The next point is 0. 0 squared, so anything squared with 0 is just 0. Multiplied by 2 is 0. Add 1, you get a positive 1. All right, in that case, that point is actually going to be our vertex. So if you remember, every point that outside that vertex mirrors itself. So in this case, that positive 1 will have a y value of 3. And that positive 2 for that x value will have a value of 9. All right, so in this case, we have that parabola. So in this case, I'm going to go ahead and graph it. So negative 2, positive 9. Negative 1, positive value of 3. 0, 1. 1, 3. And then the value of 2, 9. So again, that is going to be your parabola. And in this case, with that vertex at that value of 0, 1. All right, so that's our parabola right there. All right, now, if you remember, inverses say that we do the exact opposite, all right? One of the cool things about graphing inverses is all you have to do in order to graph those inverses once you have those points is just to flip them. So in this case, my value for negative 2, 9 now becomes a value of 9, negative 2. Coincidentally, 3 and negative 1, 3 will become the point 3, negative 1. 0, 1 will become the point 1, 0. 1, 3 will become 3, 1. And 2, 9 will become the value of 9, 2. And again, now that we have those points, now we can just graph them. So in this case, that 9, negative 2, the 3, negative 1, the 0, 1, the 3, 1, and then last but not least, that 9, 2. So in this case, it's going to look a little different, obviously, because now it's the inverse, but in this case, this is what we're going to have in that parabola right there, okay? So as you can see, usually what you would think with an inverse, it would do the opposite, right? It would flip on in this case. Not this time, actually, though. If you remember, every single time we find an inverse, right, we have a line that has what's called the axis of symmetry. And we're going to talk about this here in a second. That axis of symmetry point says that all those points mirror each other. So in this case, I could flip the other one onto the other, okay? So in this case, one of the questions we ask is this inverse a function? If we look here at this inverse, specifically if I look at this pink one, that vertical line test right there, that vertical line test says that I cannot have more than one y point for one x point. All right, so in this case, it fails the vertical line test, so therefore, we know it's not a function. Rather, our real definition for it, it is not a function because one input has more than one output. right, so that's our definition for that function there. Now, in asking what is the line of symmetry between these two graphs, if you look here, we have that line of symmetry that runs right through the origin, and it looks like we have a slope of up 1 over 1 each time. In this case, our line of symmetry is just going to be an actual linear line, all right? And this is going to be the case for every single parent graph we do, okay? No matter if we do parabolas, if we do absolute value, if we do cubic functions, it will always be that same thing for every single function, all right? So, all right, on to the next one, number 2. So number 2, they give you an actual graph now. Now your job is to actually find the points and graph the inverse, all right? So in this case, all you got to do is just find some points that it interconnects with, so x and y, and figure out how we can graph it. So in this case, I see the first point is 0, 1. Another point that I see, 2, 4. Another point I see, 3, and then 9. All right, so in this case, that is our exponential function. What we have to go ahead and do is we again just have to flip those points to get the inverse. So in this case, our inverse is going to have that xy. In this case, that 0, 1 will become 1, 0. 2, 4 will become 4, 2. And 3, 9 will become 9, 3. And now we can go ahead and graph it. So in this case, that 1, 0, the 4, 2, and then 9, 3. All right, so we're going to have that line that goes off like this, and then we're going to have a line that goes down that way. All right, and again, this is our inverse function here, so therefore we are able to actually see these points with that inverse. So in this case, our axis of symmetry, again, is going to be at that same point. Okay. And now it's asking, is the inverse, so the pink line, is that inverse a function? If we look here, have that vertical line test. I know it may look like that this line right here fails it right away, but in this case, that value is actually getting closer and closer and closer to 0 each time, right? So as the x's go to the left, or as we get closer to 0, those values will actually hit a line of asymptote. So that asymptote, again, is at that point x is equal to 0. So in this case, this thing is in fact a function. Because every input has one output. What a line of symmetry between the two graphs? My apologies. So the line of symmetry between these two graphs, y is equal to x, okay? So same thing. All right, again, this is FN2 graph transformations and inverses. Please let me know if you have any questions about this. It's pretty straightforward. I think you guys will all do well, but again, please ask me questions if you have any other things that come to mind. All right, have a good one. We'll see you later.